quantized gravity, although we know a lot about what such a theory would have in it, and one of them is, because quantum theory works beautifully, we fully expect that there would be particles like the photon, which is a particle of light, and we know that there is particles of light and there are waves of light, and the classical waves are described by the probability distribution of finding photons in an ordinary classical wave. That's the way you make that connection between classical physics and quantum physics. The same thing is going to happen when we start looking at gravitational waves. If we ever get to the point where we have to look very carefully at the waves, do we see that they're quantized? And everybody expects them to be quantized, and they even have given the particle a name. It's called the graviton. Okay? And no, but right now, I don't think it's in the cards at all for LIGO to see a graviton. Just completely out of the question when you start looking at the numbers. And I don't know when we will finally see something like that. It may not be ever, but it might come from measurements of the cosmic background, of that experiment that was the one where there is a way, and let me just say, way in the future. And this is sort of the last thing I'll say about this, because it's not something that the B modes will give us. That's this thing where you're looking at the polarization of the cosmic background. But there are ideas on the drawing boards, but not with engineers. Mostly physicists so far have drawn. So there's no real engineering that's been done on this. But of making a detector that is the size of LISA with the technology that is done on the ground.